Hello, my name is Peripherals. I'm from the JSM College of Engineering, Pune. So this is the PowerPoint presentation for the Emergency Embedded System Internship and the project. So we'll start with the PowerPoint presentation. Let's see what are the content of this PowerPoint. First, we'll see the objective. Then we'll see what I have learned from this project. Then what are the tools used. Then the peripherals used. And then the project demo and the conclusion of the project. Let's start with the objective. The objective of the internship is to develop hands-on skill in embedded system and embedded C programming through practical implementation using the PIC16F 877 microcontroller, and to build a working embedded project like washing machine, what we are doing here, involving hardware interfacing, peripheral control, and real-time logic design. So to design and implement a fully functional washing machine using PIC16F 877E capable of executing multiple wash cycles, example like wash, rinse, spin, with user input via keyboard and displaying real-time status on LCD. Well, like what CLCD we have used, using managing time-based control and signaling using embedded C and microcontroller peripherals. Let's see what I have learned. We'll start from the C programming, embedded C specific concepts. What have we learned from the embedded C specific concept from C programming? First, what data types like int, char, float, unsigned, signed, and their ranges like in a lecture, we have learned what are the data types, how are they being performed, what are they used, where are they used. To like int specifically used for what, character is char is specifically for what, unsigned char this specifically used for which type of data types we have used. Then size and sign modifiers like short, long, signed, unsigned usage. Then we have learned the operators like arithmetic operator, relational operator, logical operator, bitwise operators. This was the various operators we have learned in the internship. Then were the preprocessor like hashtag define, hashtag include. Also, we have used the macro functions in the main project what we have done. Then the conditional logic like if, else, switch cases. We have used switch cases to go through various of the modes in the washing machine. Then loops like for, while, do while to completely loop the particular condition or particular code. Then function like declaration and definition, pass by value versus pass by reference, then recursion and static variables. Then we also seen the pointers like basic pointers arithmetic and pointer to array, null pointers. Then what I've learned in the microcontroller section like embedded C programming, I guess this was the bare metal programming, as I learned to write bare metal codes. No OS we've used using xe.h header for registered level access, control input output port using tris-x and port-x registers, using bitwise operations for input output configuration and manipulation. Create modular programming using int configure, main, while one, super loop. These were the various functions and macros we've used, like use delay macros, delay ms, and delay micro s for timing. Then in microcontroller programming with PIC16F877A, pin configuration for input and output, like working with 8-bit microcontroller architecture, memory map register used for the control and data handling, port A, port E, tris-A, tris-E uses for the input output operations. Then in the digital input output control, we have used the LED control. We have seen the many peripherals like LED, then buzzer and fan, many peripherals like turning on of the single and multiple LEDs, toggling LEDs via code, handling activate high versus activate low LED circuits, switches and keypads, digital keypad interfacing with edge and level triggering, switch press detection using port B RB0 to RB05, debouncing techniques using code logics. Next, we have learned timer and interrupt handling, timer 0 and timer 2, timer configuration in prescaler, postscaler and preload, tick resolution, quantum and overflow logic, interrupts. In interrupts, we have used the ISR interrupt using flags like TMR2IF for interrupt control and enabling global and peripheral interrupts like GIE and PIE. In CLCD LCD interfacing of 4 is to 6 is to 4, 16 is to 4, we have used, by mistake I have written here 16 into 2. We have used 16 into 4 LCD in 4-bit and 8-bit mode using RS, RWEN, port D and port E lines. We have used this RS, RWEN in the macros of the header file, implementing CLCD write function, CLCD push function and CLCD print function. Cursor control printing strings characters using macros like line1x, line2x to manage text positioning. At last, we have also used buzzer and fan control. In output peripherals, control via port C, RC1 equal to buzzer and RC2 equal to fan. Logic to turn on and off fan, buzzer based on conditions or the states. Then we have what are the tools and peripherals. Tools used were the simple like Mplab IDE for writing, building, debugging the code. Then X8 compiler to compile that code for the PIC16877A microcontroller. Then we have used the Picsimlab to simulate the embedded system, as we have done various projects like for the LED, then for the fan, then for the buzzer. We have and the keypad, digital keypads. We have simulated all these projects on together in the Picsimlab. Then we have the peripherals. We have CLCD. For CLCD, we use the display status like in the washing machine, like washing, then rinsing, power on, key, press key 5. All these characters have been displayed on the CLCD. And the keypad, user input for the mode selection or the start stop control. To the keypad, we have used the digital keypad for how much time we press the button or what button we press, according to that what function should be executed is being done by keypad. Then the buzzer, that's audio signaling, as we know at the end of the uh, at the end of the washing machine, when the washing machine completes its function, the buzzer rings, and when we open the washing machine, then also the buzzer rings. The buzzer has been used here. The motor slash fan, we have used the fan which is simulating the spinning operation of the washing machine. Then we have used the switches, with switches used for the start or pause of the manual override options, and the LEDs to indicate mode, timer modules to manage timing for the washing cycles, interrupts, detect key press or emergency stops instantly. Then we'll go to the simulation. So this is the simulation part of the washing machine. We'll just start with the simulation. I'll just load the hex file once again. Or rather we can just press the reset button. We can reset the machine. Okay. So this is the reset button. This is our PIC microcontroller. This is the 7-segment display. This is the CLCD and this is the fan and the motor. This is our buzzer. Now it says press 5 key 5 to power on the washing machine. So we'll just press the key 5 and we will power on the washing machine. As you can see, when we press the key 5, the powering on washing machine prints. So the washing program has, these are the various program for the washing machine according to the clothes, which we can select. There are numerous programs like daily, heavy, delicate. We can change and go through the various program like heavy, delicate, then whites, then stain wash. Then we can see as eco cottons. So these we can toggle through various programs just by clicking on the switch 4. That is switch 4. We can just click on it and we can maneuver through various of the programs for the washing machine. So how do we select it? We will just tap and hold the one of the program to select it. See, as we have tap and hold the Aqua Store. This program has been selected. Now we have to select the water level. There are various water levels like auto, low, medium. So for the reference, I'm just selecting the auto. As the auto has been selected, we have shown switch 5 and switch 6, which in switch 5 the machine will start, and the switch 6 we can stop the machine when it starts. This will indicate how we will start the machine and how we'll stop the machine. For reference, we'll start the machine now. As we will start the machine, a timer will start. The timer is managed by timer function. The timer of 50 seconds has been started. As we can see that fan is also moving. The fan is simulating the motor for the washing machine. As we have plenty of time of 30 seconds, we will discuss the start and pause function of the washing machine, also the door opening of the washing machine. Like how if the door opens, what it will be causing, and if the door is closed, what it will be causing. We'll just see the pause function first. As I was clicking for 6, the machine has been stopped, the fan has been stopped working. We'll just enable it once again, and we'll see the what if we open the door. So we have the RB not switch. By clicking it, we have simulated it as we have conducted it as the door open. As I will click it. Yes, you can see that door has been closed. We have seen the notification. Also, the buzzer is also started to buzz. As we have connected it, as we have pressed RB0 again, it simulates that the door is closed. As we can see, the done washing machine has been implemented and the buzzer was also rang according to it. So this was the simulation, and you can see as here that the motor as well as the fan, when we click the pause button, the both motor and the fan both, and when resume, starts working. So this was a simulation for the washing machine. Thank you so much. Now we will talk about the conclusion of this project and the internship. This internship really provided an hands-on experience to me in embedded system using the PIC16F877A microcontroller. I learned embedded C programming, GPIO controls, timer, interrupts, LCD, and keypad interfacing. Also, very different peripherals. Also, I've learned and built a fully functional washing machine project. I'm really glad that I've completed this project and presented this to you. I also gained practical skills with tools like Mplab IDE, X8 compiler, and Picsimlab. Overall, the internship strengthened my technical foundation and prepared me for a real-world embedded system development. I will really like to thank you, the Emertex Information Technology, for giving us this opportunity of doing this internship. And thank you so much. Thank you.